Welcome to YouTube channel Kang Lepak Study Support. Today's topics are concentration of ores by chemical methods. In this section, we will discuss calcination, roasting, and leaching. So, without wasting any time, let's begin the class. Concentration of ores by chemical methods. First, let us discuss calcination. It involves heating of the ore below its fusion temperature in absence of air. It removes moisture from the hydrated oxide ores or carbon dioxide from the carbonate ores. That means calcination is a process of heating the ores below its fusion temperature in absence of air. Okay, clear? During calcination, moisture is removed from the hydrated oxide ores or carbon dioxide is removed from the carbonate ores. So let us see by taking some examples. Al2O3, 2 molecules of water, this is bauxite ore. Okay, when this bauxite ore is calcined below its fusion temperature in absence of air, that means heating, this bauxite ore is converted into aluminum oxide Al2O3 and water vapor. As bauxite is hydrated oxide ore, water vapor is removed from this bauxite ore. Okay. Next is calcium carbonate. Calcium carbonate is a carbonate ore. When this calcium carbonate ore is calcined below its fusion temperature in the absence of air, it is converted into calcium oxide and carbon dioxide. So carbon dioxide is removed from the calcium carbonate. Okay. Again, zinc carbonate. Yes, it is also a carbonate ore. When it is calcined below its fusion temperature in the absence of air, it is converted into zinc oxide and carbon dioxide. Okay, clear? Next is roasting. It involves heating of the ore in presence of air below its fusion temperature. It is mainly used in case of sulfide ores. Due to roasting, the moisture and volatile impurities are removed and the ore is converted to oxide. Okay. For example, impurities of sulfur, arsenic, and phosphorus are removed in form of volatile oxides. For example, sulfur as sulfur dioxide, arsenic as arsenic oxide, and phosphorus as phosphorus oxide, respectively. So, what is roasting? Roasting is the process of heating of the ore below its fusion temperature in presence of air. Okay. In calcination, the ore is heated below its fusion temperature in absence of air, but in roasting, ore is heated below its fusion temperature in presence of air. Okay, this is the difference between roasting and calcination. Roasting is mainly applicable in case of sulfide ores. Due to roasting, the moisture and volatile impurities present in the ore are removed and the ore is converted to oxide ore. Okay. For example, if sulfur, arsenic, and phosphorus, etc. are present as impurities in that ore, due to roasting, the sulfur, arsenic, and phosphorus are removed in the form of their volatile oxides such as sulfur dioxide, arsenic oxide, and phosphorus oxide, respectively. Okay, clear? So, FeS2, it is an ore. If it is roasted, roasted means heating in presence of air below its fusion temperature. Okay. This FeS2 is converted into its oxide ore Fe2O3 and the sulfur present in that ore is removed as sulfur dioxide. Okay. In the same manner, Cu2S, this is ore, sulfide ore of copper. Okay. When it is roasted in presence of air below its fusion temperature, this sulfide ore of copper Cu2S is converted into its oxide ore Cu2O and the sulfur present in that sulfide ore is removed as volatile impurities sulfur dioxide. Okay. In the same manner, zinc sulfide ZnS also it is a sulfide ore of zinc. Okay. When it is roasted in presence of air below its fusion temperature, this zinc sulfide is converted into zinc oxide, and sulfur present in that zinc sulfide is removed as sulfur dioxide. Like that, lead sulfide PbS also is a sulfide ore of lead. Okay, when it is roasted in presence of air below its fusion temperature, this lead sulfide is converted into lead oxide, and the sulfur present in that lead sulfide is removed as sulfur dioxide. Okay, clear. Next is leaching. Leaching is also a chemical method to concentrate the ores. Okay. Leaching involves the treating of the ore with a suitable dissolving agent. So, the ore is dissolved in that suitable dissolving agent and remain as aqueous solution. But the impurities present in that ore are leaving behind as insoluble impurities. Okay. For example, bauxite, which is an oxide ore of aluminum, is treated with sodium hydroxide solution. Al2O3 present in bauxite ore is being amphoteric, dissolves in sodium hydroxide solution, while the impurities present in that bauxite ore like Fe2O3 and silicon dioxide, etc., are unaffected. So they are remain as insoluble impurities. The reaction is Al2O3. This is bauxite ore. When it dissolves in sodium hydroxide in aqueous solution, so aqueous solution means water is present. It dissolves in sodium hydroxide solution and forms sodium aluminum hydroxide, NaAlOH whole into 4. This sodium aluminum hydroxide in solution is neutralized by carbon dioxide, and hydrated aluminum oxide is precipitated. So the reaction is, when the carbon dioxide is passed to sodium aluminum hydroxide, it is converted into aluminum oxide trihydrate, Al2O3, 3 molecules of water, and sodium bicarbonate, NaHCO3. Okay. Aluminum oxide trihydrate Al2O3, 3 molecules of water is in solid state. Okay. And sodium bicarbonate is in aqueous solution. The hydrated alumina, which is present as solid state, is filtered and dried and heated to get pure aluminum oxide. Okay. The reaction is Al2O3, 3 molecules of water means aluminum oxide trihydrate, which is present as solid state, is filtered and dried at 1470 Kelvin. So, aluminum oxide trihydrate Al2O3, 3 molecules of water is converted into aluminum oxide Al2O3, which is solid, and water molecules present in aluminum oxide trihydrate is removed as vapor.